As Don said, my name is Jeff Bonkoski. I'm a retired career firefighter. I worked for a community just south of city of Detroit, which was Trenton, Michigan, where I've spent and retired out as a captain. I trained to the level of a hazmat specialist and was a paramedic. So spent a lot of my time and through my career learning as much as I could about the high hazard fires that firefighters are faced with. And upon retiring, started doing consulting work, and that consulting work led me to F500, feeling that in the 21st century, there should be an agent out on the market that can deal with some of the 21st century fires that we're faced with. And today, what I would like to do is share with you what I've learned, basically, and how to make things safer, make things not only within our workplaces, our warehouses and buildings, but also for firefighters who are called upon and our first responders who are called upon when we have fires in these types of buildings. So the mission of HCT is much the same as what I was hoping to do is through fire prevention, be a leader in offering protection and suppression utilizing eco-friendly, innovative technology. And we'll see how when we talk about encapsulator agent F500, we're going to be talking about an agent that is fluorine free. Where with foams, we have to worry about the forever chemicals, the PFOS and the PFOAs. We'll talk about the differences and how this is so much safer than those agents. We do have the engineered systems, which we're going to be talking about, emergency response, the training and consulting, and doing demos and things that Sernan mentioned at the very beginning. HCT has been around since 1997, and we're worldwide, based out of Fayetteville, excuse me, thinking back at home. It's there in Georgia, that we have our headquarters, and then again we have our offices throughout the world. Getting tongue-tied here, excuse me. And we're trying to be stewards in the industry. We're trying to be as active as we can with the Society of Fire Protection Engineers, NFPA and ISTA, and trying to get this new technology into the standards. It's been long and it's tedious, but we're working, and hopefully with people that are joining in with us today, they can see the benefits of these F500 in the water stream, in helping to suppress these fires and being able to control them, and hopefully join the fight in getting these standards changed to make it safer. We are members, as I said, of the NFPA. We sit on committees. We're an ISO 9001 registered company, which we're very proud of. Quality control is very, very important to us. And when we sit here, we start looking at, as I mentioned, the high hazards that we're faced with, probably one of the fastest growing hazards, not only in industry, but, in our everyday world, is lithium ion batteries. And some of the other things that, we've had issues with is the three-dimensional fires, where foams aren't designed and can't. And even in Annex A11 of the foam standard, it states that foams aren't suitable for three-dimensional fires, yet more than 90% of the fires that firefighters and we're faced with are three-dimensional. And then we start getting into the Class D metals and the titaniums and trying to make buildings or vehicles or things stronger and lighter weight. We're using some of these exotic metals in order to do so. And then solar panels, we see them popping up on the rooftops of pretty much schools, buildings, parking garages, houses. They're all over. And as we go through, I'm hoping that I give a better understanding of not only the encapsulator agent, but how it can be used in what we call our concentrate control systems. Being able to encapsulate the features of it, the applications, how it can be used in the fixed systems and the different types of fixed systems, and some of examples in some of the projects that we've already been used in. So hopefully I can get to you and get across the difference between foam and an encapsulator agent, um, get and talk about the applications so that we understand, what percentages we need for what types of building materials or what type of occupancies, and then into different industries and emergencies. Start with
The old and familiar representation of a fire triangle has been replaced with a fire tetrahedron because we now know and recognize a fourth element crucial to combustion, a chemical chain reaction. The four sides of a tetrahedron represent the four components of fire: heat, fuel, oxidizing agent, and the chemical chain reaction. If any one or more of these components are absent, a fire cannot occur. When all four components are present, heat, fuel, oxidizing agent, and the chemical chain reaction, fire will occur. There are four options for extinguishment: cut off oxygen, cut off fuel supply, thermal insulation of the fuel, and interruption of the chemical chain reaction. When one or more of the components are removed, the flame goes out.
now what I want to talk about when we talk about foams. Okay, foam again works on that two-dimensional aspect of the fire, causing a separation. It separates the oxygen from the fuel from the heat. And unless you're there to continually reapply that foam blanket until that heat cools down below the auto ignition temperature, if that blanket breaks apart, the heat's still there, you have reignition. When we sit there and we start talking about water also and use on a structure fire or fires, generally what we're doing is we're changing the H2O molecules to steam, and we're hoping and we're using it to try to help smother the fire. So very, very ineffective way. We're probably using maybe 3% of a water droplet to cool and extinguish a fire, and the biggest majority of that water runs off. It's not used anymore. When we sit there and start talking about encapsulator agent, we're not going to work on being able to blanket. We're going to talk about how an encapsulator agent is rapidly able to reduce and eliminate the heat permanently, how we're going to be able to encapsulate fuels, and how we're going to interrupt that free radical, and how we're able to help reduce the soot, the toxins, and making the oxygen in the atmosphere cleaner, safer, without all of the toxins and the hazards that you need, which is important because how many times when we have these fires at some of these large buildings are we causing, because of the contents in the building, evacuations of neighborhoods? Okay, so if we can have a better effect in being able to introduce something into systems that are in these buildings, which we'll talk about, we can possibly reduce that. And again, just as a real quick recap, when we look at, NFPA 18 wetting agents, all we're doing is making a water droplet smaller. We're giving it some ability to penetrate into smaller cracks and crevices. And again, we're still using steam. When we talk about the foams, okay, creating that blanket, causing that separation, again, nothing to really remove the heat. And we'll see as we go through how, as we start getting into some of the, lithium ion battery hazards and some of the other hazards, the foams are very ineffective. When we look at the encapsulator agent and NFPA, there's a lot of new information in the new standard that was just released, the 2022 edition. And we're going to see how much more effective an agent in this category is of being able to reduce the heat, to make flammable liquids non-flammable, not ignitable. And in essence, we're going to take what regular water droplet that was maybe 3 to 5% effective at being able to cool and extinguishing, and now we're going to turn that water droplet into an agent that's going to make that 95% effective at cooling. We're going to use much more of that water to be able to cool and extinguish fires. Start with, we're not going to be talking about foam. We're not going to be talking about bubbles. You're going to hear me talk a lot about spherical micelles. and what is a spherical micelle and how those spherical micelles work, and being able to encapsulate your carbon molecules and, both polar and non-polar. And we're going to see that, they can do so much more. It starts getting into being able to reduce the soot and the toxins, and how it's able to work on that chemical molecular basis, not a mechanical basis like foams. Excuse me. So we've been around in the standard 1996. Like I say, it was the first water additive was purchased or by HCT. It was reformulated. We now have F500, and we've learned that it's worked and are very effective on all classes of fires. Your class A, B, D, and in the standard 2022 edition, if we go into 18A and the annex materials 4.3, we're going to see that there's even information that has testing or shows that, people have tested, third-party agencies have tested on lithium-ion batteries with promising results, very effective. And the test continues, and we're even finding out more and how it's able to reduce the toxins being released by lithium-ion batteries, how it's able to encapsulate the electrolytes, rendering them non-flammable, not ignitable, reducing the water runoff. We hear, multiple times when we hear about lithium-ion batteries burning thousands and thousands and thousands of gallons of water being used to fight a lithium-ion battery. But yet when we look at testing that's been done by all these third-party agencies and all these third-party groups, they're being able to extinguish these batteries with, a fraction of the water that they use in the same test. So we'll see how, these can be very effective by using F500 into your water streams in dealing with not being able to just control a fire, possibly in a manufacturing building or in a workplace, but being able to extinguish it before a fire department even arrives on scene. So when we sit there and we look at the NFPA 18A standard in section 7.7, it addresses the spherical micelle stability test. And the test is we take a gallon of a flammable liquid, we take 16 ounces of the concentrate and 5 gallons of water. After that is turned into a solution, it's allowed to set for 1 minute. At the end of 1 minute, a torch would be passed across the entire surface of that pan, and there can be no visible flames.
Encapsulator Technology.
One too fast. At the end of that initial flame test, that solution now sits for 2 hours. And at the end of 2 hours, the flame will again be passed across the entire surface of the pan. And again, there can be no visible flames. And the test can go on and on and on until that evaporates away. There will be no visible flames throughout that evaporation process. This video is very important. As I mentioned early on, we're going to be talking a lot about spherical micelles, not bubbles. And to give you an understanding of a spherical micelle, you need to start with our simple molecule. The molecule has a polar head, which loves water, wants everything to do to be near or by water, and then the nonpolar tail, which fears water. It wants nothing to do with water. So when the concentrate gets mixed into the water, because those tails want to get away, those molecules orientate into these spherical micelles. Okay, all those tails are curved in, so we make these spherical micelles. When it comes out of a sprinkler head or through a fire nozzle, we see that this molecules closest to the surface, they break apart. Now we've put a skin on the surface of each and every water droplet. We've chemically changed that makeup, and not only have we changed it, but now we've changed the mechanism of cooling and extinguishing because of doing that. Yet inside of each and every spherical micelle are still millions and millions of these spherical micelles, excuse me, inside of each water droplet. To give you an
Encapsulate
of how many, Um, if we were to, as a visual, think of the Earth as the size of a water droplet, the spherical micelles inside of that would be a pea. So there's, again, just that visual, millions and millions of these spherical micelles, and those are what's helping us to encapsulate those flammable liquids and flammable gases that we are working to eliminate and trying to help clean the atmosphere as far as the toxins and the soots that we're also seeing. And when we watch videos, you'll see black smoke turning to a white color, and we'll give you a better understanding of how that's happening as well. So the unique features of the product are encapsulation of the toxic soots, the gases, the polar solvents, non-polar solvents, and most recently, in some reporting, we're finding out that we're having an effect in being able to reduce hydrogen. Biggest hazard when we deal with many flammables, Class D metals. What's the problem when we deal with the Class D metals? They burn so hot that they cause the water molecule to break into its two properties, hydrogen and oxygen. We're creating an explosive atmosphere. But yet when we start using F500 on those Class D metals, we don't have that. One, because we're putting that skin on the surface of the water droplet, so it's not truly the water. But now, from some testing that we just received, we're finding out that we're able to encapsulate and reduce that hydrogen levels as well. So we're working again on multiple bases when we deal with these different types of fires. That rapid cooling, being able to take temperatures that are in excess of 1,200 degrees and dropping it down to about 120 degrees in a matter of seconds. It's permanent heat reduction. We're getting rid of that ignition source. That foam has to be applied to over and over and over again until we get down below the auto ignition temperature. I've mentioned it many times, and I'm going to continue to mention that toxin reduction, not only in just ordinary, structure fires because of the building materials, but also when we sit there and start looking at lithium ion batteries and the gases being released. And as I said earlier, that fluorine free, there's no forever chemicals. So when we look at rendering a spherical micelle, we look at that spherical micelle stability test. And how it's able to work. I mentioned it. It's covered in section 7.7 in NFPA 18A. And once that flammable liquid has been encapsulated, it will not reignite. Okay. When we look at the thermal circuit, again, we need to look at and remember that animation that we just showed, how we changed the makeup of that water droplet. By changing the makeup of the water droplet, what we've done is we've basically used that skin and those tails that are on the outside of the surface. They drive the heat inside, okay, and rapidly absorb it. When we talk about those flammable liquids again, okay, we need to know that there is a ratio. Some people might think if we just get, a little bit of, the concentrate or the solution into a, large quantity of a fuel, that we've basically ruined all of it. And there isn't. That's not the case. There's a ratio. It's 1 part of the F500, 8 parts of fuel, 40 parts of water. The kinetic energy is the splashing. If it's a spill on the ground and you're spraying the ground, the kinetic energy is the water splashing against the ground and helping to drive and helping to encapsulate that solution. The ratio is a 1 to 5. And when we look at the percentage as far as a solution, it's a 2.5%. And when we, as firefighters or, people in the industry, our eductors and most of our equipment is set up at 3%. So there's a slight safety margin involved when we do that. The other thing I've mentioned right from the start with the triangle, that reduction of the toxins, that ability to reduce the hydrogen fluoride with lithium ion batteries, that HF gas, being able to reduce the carcinogens, the toxins. And what we're doing is we're not so much interfering with we're not encapsulating the smoke. And this is a test that it was done by Clemson University. And what they did is watched videos, saw black smoke turning white, and the question was asked, why? And this test came about, and what they did is they made an inverted glass funnel, and they were looking at three things. They were looking at light transmission through the smoke column. They were looking at how much soot built up on the walls of the funnel, and then they looked at the toxicity. And they used toluene as their fuel source. They did a series of tests using the F500 at a 3% solution, and they found that there was a 68% increase in visibility, a 97% reduction in soot, and a 98.6% reduction in toxins. In today's house fires, what's killing people faster? Okay, versus, when we sit there and start looking at, our legacy fires versus today's fires, a room and contents, 30, 40 years ago, it might take it, 20 minutes before it built up to a temperature or would flash. And today it might take it, a minute and a half to 3 minutes to a point to get to that same level. And because of all the materials that are being used, the toxins that are being released. How many times do we hear about firefighters falling through roofs because they're up on a roof trying to cut a hole to ventilate, to improve the visibility, to get rid of the heat? I just talked about how we're able to reduce the heat. You just saw from that Clemson report how we're able to improve the visibility, 68%, and that soot. So we could have benefits in being able to deal with these fires early on and prevent, injuries from people trying to get up and ventilate roofs or and trying to, get the heat out. Not only that, but what happens if we have people that are trapped within those buildings trying to get out? If the fire is growing quickly, okay, and we have this in the systems, we can reduce those toxins, we can reduce the heat, we can improve the ability for any victims that might be injured or trying to evacuate a structure. We can have an effect on being able to make those conditions better for them. No PFOS and PFOAs. It says the crisis is ahead. Well, it's here. There are many states that are already banning the use of PFOA and PFOS and Class B foams. There's many that are doing buybacks. Okay, just trying to get it out of the fire service. There are states that are treating the use of a Class B foam like a hazmat incident, where it needs to be reported and needs to be documented within the state and needs to be tracked. So, these foams are being banned, and the push is for green foams, fluorine-free foam solutions. And I often caution after reading and watching and looking at SDSs, what chemicals are they trading the PFOS and the PFOAs for? What other effects could we be introducing into the fire service or into the community? Here we talk about encapsulator agent, that we've had, many environmental tests, studies. We've tested for fluorinated ingredients and found none. And I often tease people, because if you have fluorinated drinking water and you use F500, you're contaminating our product with your fluorinated water. Just a little, I guess, humor. When we sit there, we start thinking about our training, we start thinking just about, what's taking place. So as far as our applications, we can deal with all the classes of fires. We have the Class A fires, Class B fires. Not only when we talk about Class B, but it's the 2-dimensional as well as the 3-dimensional Class B fires. Class C fires. When we talk about Class C fires, we're talking those stored energy. Okay. Or if we talk about transformers, it's a transformer that has failed. It's no longer arcing. It's no longer sparking. So it's now a Class B fire. It's the oil in the transformer. And we'll see a case study on that here in a bit. But it's a Class B fire in a Class C environment. Then we get into the Class D, and then lithium ion and spill control. So we could have an effect and be able to be used on all of these different areas. When we look at lithium ion battery,
hazard.
okay, the test came to us from Kiwa, but we're going to see in the introductory video here all the different classes of fires. Really would like you to pay attention. In this, the pallets on the left have been pre-treated. Okay, so we saw that they were able to take some heat without burning. Black smoke turning white, tire fire. Here we have a car fire. And I point out, look how little water runoff, okay? 20 gallon per minute nozzle. Being able to extinguish, again, black smoke turning white quickly. Here's a class B fire, two-dimensional, but still, foam only has 3 application techniques. Here's a polar solvent. Same thing, aggressively fighting the fire with foam, only those 3 application techniques. Rain it down, bank it in, roll it on. The 3-dimensional fire that the foam Annex A11 states foam cannot extinguish. Here with an encapsulator agent, able to extinguish it. Flammable gases, being able to extinguish and being able to control those rapidly. The lithium ion batteries that take, when we sit there and, we listen to some of the experts here in the US, copious amounts of water. It looks to me like he's getting that battery under control rather quickly with just a small amount. That class D metal, okay? We've put that skin on the surface of each and every water droplet. We've changed that cooling mechanism. Okay, not only are we cooling, but when we're reducing that hydrogen gas. I said earlier about the transformers. Okay, this transformer has failed. It's the oils in the transformer that are burning. So it's now a class B fire in a class C environment. So yeah, I'm going to start getting now into what we're all here about to learn. Okay, these fixed systems within our structures and our buildings and the different types of methods that we can use to help protect them, the bladder tank systems, the water driven proportioners, how we can work on, turbine lube oil systems, transformer systems. We can work in warehouses. We can work pretty much in any application where you currently are putting a sprinkler system. We can have an effect in being able to control and extinguish those fires. Okay, again, we just see some buildings. When we use the F500, with concentrate control systems, our shelvings, here we have, a large fire that's, factory, pulp and paper, your pharmaceuticals. It can happen any place. And in all of these different facilities, okay, F500 can be used. So we're losing billions and billions of dollars. And while water might be able to control it, F500 can be able to have a much better effect. And it shows some of our success here, our success stories, with an Alabama power company. And we'll see this some more. 3 minutes and 10 seconds with an encapsulator an encapsulator system. It was a bladder tank. We're going to talk about water driven proportioners, the balanced pressure pump systems, and we'll be talking also about your water driven proportioners. We want to hopefully get you interested in giving us a call so that we can help you with some of the high hazard buildings or some of the high hazard occupancies that you may be dealing with. Let me back that one up again. When we sit there, we start looking at, some of these, well, wants to just go ahead on me. Look, when we start looking at some of these, different structures, I kind of went through real quick there on me. Sorry about that. Must have hit that as a play, but we look at the warehouse, the person coming through, look at the height of our ceilings. Okay, and many times when we have these sprinkler systems that are designed, and we have these different situations, and here's a classic example. Okay, here we have an ordinary facility, manufacturing facility, a lithium ion powered high-low. And I asked the question, what in all of our buildings is the required extinguisher? It's a dry powder. It's an ABC. In every building, in your schools, in your high rises, in your offices, okay, everywhere, ABC is a recommended extinguishing agent. So the employees are running around throughout this manufacturing facility. And yeah, the fire is pretty intense right now. We're getting some heat. So they're getting their ABC extinguishers and they're doing their best to work and extinguish this fire so that they can get back to work, keeping the heat down. You know, what are the sprinkler heads? What's the temperature rating on the sprinkler heads above? Until we hit to that temperature at that height, okay, that system is not going to be activated. So as we can see from their attempt, it didn't work. Dry powder didn't work in that lithium ion battery. And now we're going to see that high-low starts to roll further into the facility. And needless to say, this facility was a total loss. That's just one. We can sit there, we can start looking at other cases. Okay, here's a case where, you know, Goodyear was working to try to increase their storage. They wanted to go from, you know, they wanted to go one rack higher, because in peak times, they were required, or they needed to rent additional warehouse spacing. So if they were able to go one rack higher on their storage, they could save money and basically pay for a system. So here we're showing that, you know, testing was done. They were looking at trying to come up with a better solution, better fire protection system, and testing foams and F500. They found that they could add F500 into the system. And by doing so, they could go that additional one rack higher, keep the sprinkler density that it was 0.6 gallons per minute per square foot. You know, so they were able to keep that density and add F500 and go one rack higher. And they found that with that use, it was actually better than what they were considering, which was reducing the sprinkler density and then adding a high expansion foam system or a foam system there. When we sit there and we look at another incidence, okay, we have Embrower down in Brazil. They were looking for a solution as well for their warehouse with the composite materials that we make aircraft with. And they were looking at, you know, water systems, they were looking at foam, and they were looking at F500. And when they did the testing, they found that with foam was just slightly better than water. But when they added F500 into the system, okay, it was much better. Okay, and being able to, I don't know what's going on here. It's going into its automatic play.
Huge flames erupting at a Pepsi-Cola factory.
Only Newscopter
We
7
sit there,
has
we
pictures
continue
like this.
watching
The
some of
fire in
our
the Middlesex County township of Piscataway.
in some of our other incidences that have taken place. You know, here we have, you know, a warehouse that's burning down. It's you know, I believe it was Coca-Cola that was there. We have Walmart not too long ago in Indiana, where again, the fire system was overcome. Okay. When the building was built, okay, did that fire load or, you know, change? You know, if that was built 15 years ago, 10 years ago, I mean, did it have the amount of lithium ion batteries that it does today? What other types of materials or what other types of things are being moved through that warehouse structure that has changed the fire load? But yet the fire system hasn't kept up with it. So we're getting these huge fire loads that are just overwhelming the current fire systems. And it doesn't mean that we need to necessarily replace them. Why can't we just add something into the water that's going to enhance the ability of that water to be able to deal with these fires? And I just, again, recently saw what in Georgia, we were talking a little bit about, what happened in Georgia at a regular Walmart store. Just recently, they had a fire that ruined it. But I kind of went through and just listed a few, just kind of hitting them. And here at the bottom two was at the distribution center there in Plainsfield, Indiana, and the Pepsi factory in Piscataway, New Jersey. But we have others, and they continue on. I mean, again, I just mentioned, there was the Walmart, and I believe there was a Home Depot that happened just recently. But we continue to see where a small fire in a facility, in a Walmart, in a hardware store, is getting away and causing massive amounts of damage, okay, because of the ineffectiveness of that fire extinguisher being able to keep up with the fire. And it's the firefighters that have to come in now and start to deal with it. And when I sit there and I start saying, hey, the firefighters, again, I'm having been a firefighter, being in their shoes, I know that when we get to those types of things, we have heavy smoke conditions. Okay, we've got smoke, we have to get our way through. And we have the opportunity for firefighters to become disorientated, okay, and perish because of that fact. We're getting better because of training and things like that, but still that opportunity exists. If a shelf is to tip over or something is to happen, again, firefighters up on the roof trying to ventilate, cut holes so that they can get the smoke and the heat out. And I know in some instances we're putting roof vents up on top of the roof that are activated by heat, but still, firefighters are going to get up there and they're going to be doing things. If we can sit there and we can start adding agents and we can start putting products into our water that is going to reduce the heat, reduce the smoke, improve the visibility, help the firefighters find that fire faster, quicker, guess what? Causing less water damage. Okay. If we're causing less damage inside the structure, inside the building, we're getting that structure, we're getting that business, we're getting that occupancy, whoever the owner of that building is, we're getting them back up and running again. So when we look at our bladder tanks, the water, the bladder tanks have, the bladder inside of the tank. We have the water. It activates when the sprinkler goes off. It pushes against that bladder, squeezing it, forcing the concentrate up. It's going through that controller and going into whatever the mixed rate is. So we see how, the water comes up out of the pipe, gets in through the different check valves and adds into the water stream to be introduced into the water. And it's showing you here just some other parts of the system, your deluge nozzle piping. And here we'll see that, yes, F500 can be added into those tanks, into those bladder systems. And again, I'm going to mention and point out that we'll be looking at some balanced pressure pump systems as well as water driven proportioners. So we work in all these different. Here's a case history. This is a Lamar power plant. And we'll see it's a 36-gallon bladder tank. We got actually different sizes, that are protecting different areas. Okay, this 50 gallons looking at protecting a conveyor system and a day silo as well as a dust collector. Okay, we got another 100-gallon bladder system that's protecting a transfer house and a crusher house, and a reclaim tunnel. So we've, in some of these facilities, have multiple systems being able to protect all areas of the plant. Your under turbine lube oil, conveyor belts, as it said. Excel Energy, we've got some in these different facilities, the Bayport, Minnesota, Earth, Texas, and Amarillo, Texas, looking at the dust collectors, ways to sit there and protect those and keep those areas safer. Because we know with foams are ineffective. And with water, how many times have we seen massive fireballs when we try to use water in a dust collector? The water-driven proportioners are probably one of the, as far as maintenance is concerned, the easiest to help maintain and to work with. A real quick video that talks about our diamond doser. It's a very reliable, easy to use. It works by water, so there's no electricity. There's no other method that is needed. What happens is you'll see as water passes through, it's going to turn these wheels, these gears, and as water flows faster, okay, those will turn faster and they will add more concentrate into the water. So these have a range of gallons per minute that they will operate at. And we will work with our fire protection contractors in sizing up the correct pump for the applications that are needed. But as you see, it shows the water coming in, it turns the wheel, it causes the pump to then start to turn. As it turns, it will activate and cause the concentrate to be introduced into the water stream at the percentage that's needed, be it now 1% to 3%. Based on the occupancy of or the fire load, if it's a flammable liquids, if it's lithium ion batteries, class D metals, you're looking at the 3%. If we're looking more towards the class A, we're looking at 1%. So again, those percentages for the occupancy and the fire load will be calculated, and then the duration, your flow times, and all the things, those will all be worked, and we'll work with you to help with that design. And here's an example. This is just showing, here we have a tote with a basically a containment. As you can see, it's elevated, so it's gravity fed. There's no, again, electricity. There's no pump that's needed. You have your water driven proportioner, and like I say, your flow controls. Once the water starts flowing through, the pump will activate and juice concentrate up into the water system, into the sprinklers, and works on being able to help cool it. Adds the agent in and starts to work on being able to reduce the soot, the toxins, the heat, the smoke. Works on those three-dimensional fires, the under turbine lube oil systems, the class Bs, all the different types of fires. But when we sit there and start looking at water, okay, is water always the approach? I'm dealing with some, areas now where you are set up where you have maybe a 0.3 sprinkler density currently, but we're finding out that, well, maybe 0.3 is not enough. We need to go to a 0.6. So is water always the most effective, especially when we come to class B fires? Okay, if we're dealing with hardware stores where we have, our oils, we have, our various types of insecticides and different things that we have throughout our hardware stores. We do have some class Bs. Foams, again, create that blanket. They do nothing to eliminate the heat. They're not suitable for that three-dimensional fire. Encapsulator agents are very able to work on those three-dimensional fires, as you saw from that mock-up of that jet engine cowling, where it was able to work because it's working on multiple aspects of that three-dimensional fire. That was a steel mock-up of an engine. It's working on cooling that steel rapidly. It's working on encapsulating those flammable vapors and being able to render those flammable liquids as non-flammable, not ignitable. So it works on multiple aspects. It's not just like foam trying to cause a separation. Under turbine lube oil protection. Again, it's showing, how with some of the fires and some of the testing with FM Global, we're talking reaching temperatures in excess of 1500 degrees at the ceiling. And how they're sitting there, and because of these high temperatures, they're starting to go and saying that we need to increase our sprinkler densities. The sprinkler densities that are currently in place aren't adequate, so they started putting out bulletins and making recommendations for a higher flow. And once you sit there and start looking at some of these older facilities, we could be looking at millions and millions and millions of dollars and having to replace water mains and all the piping. It can get rather expensive. So the question comes again, okay, what would happen if we were to add F500 encapsulator agent into the water stream? Can that offer enough cooling? Can that offer enough of an enhancement to that water that we can maintain and keep the sprinkler density that's we currently have? And this is just some testing that was done with come on, my video with Dominion. It's showing a spray density of F500 at 0.2 gallons versus water. Pre-burn, it's showing 11 to 1500 degrees.
11, 10. 1200 degrees. 200. Fire's out. Fire's out.
Okay, so here's just an example. At a sprinkler density of 0.2 with a class B liquid, okay, F500 at 3% was able to extinguish that fire in 11 seconds. At a 0.2 gallons per minute per square foot, we're at 4 gallons per minute per square foot. It took it 30 seconds. Much greater ability to reduce the heat and being able to extinguish. So when we look at some of the systems in our structure where, hopefully the system to maintain the fire until the fire department can arrive and extinguish it, now we're putting an agent into the water stream that's going to extinguish the fire. That's going to be able to reduce, again, the amount of fire damage, reduce the amount of smoke damage, the heat damage. And again, this is just a chart showing, even the temperature and time. How when you sat there and you started looking at the F500, you went from, that 1300 degrees down to 200 degrees in 10 seconds versus with water. I mean, it was, somewhat fast, got down to 400 and it kind of curved. Excuse me. And it took it a while to get to a point to where it was able to cool and to be able to extinguish. So the test results come back that, hey, it's 3 times faster than what is being recommended. So Dominion was able to add F500 into their existing systems, okay? And by doing so, we're giving better fire protection than what was being recommended, okay, at their facilities, okay, under turbine lube oil, on the deck protection, all these different areas. And then we get into some other testing because, I've been talking about, class D metals. We're not talking about the oil industry, the, lube oils and things like that. And this test was done and it was basically to see how effective adding F500 into a sprinkler system would be when you start talking about foams and mattresses. And the proposal was they were going to do a water-based system. And then the second test was going to be a water-based system using encapsulator agent at 1%. It wasn't a lot. Okay, so when they did the water, They were going to use just, pretty much the sprinkler system. They're going to use the heads, the encapsulated heads. And when they did the test, excuse me, okay, they looked at the water. They used 1,000 liters, excuse me, of water. Okay, they used 100% of the water, and they were not able to extinguish the fire. Okay, didn't extinguish it. Right here, with 1% of F500 in the water. Again, same 1,000 liters, but let's look at the density. Okay, here, 0.4, at 1%, 0.2. Let's look at the pump pressure. Okay, 40 PSI down to 10 PSI. Okay, didn't extinguish it with water. It was 20 seconds with 1% of F500. Okay, so what 1,000 liters couldn't extinguish, 50 liters was able to extinguish it. So when we sit there and start trying to figure out how much of a difference can adding F500 encapsulator agent into an existing sprinkler system offer, here is a good example. Okay, how else can we do it? I don't know if this report will pop up. I'll have Hernan show that report at the end. But again, it just covers the whole layout of the testing that was done. We look at the transformers, the fire protections, and the transformers. And we see again with all these different incidents that take place where we have these and depending on what locations, some of these transformers, we heard many years ago, PCBs. Yeah, well, the power industry has done their very, very best to eliminate and get rid of the PCBs. I know, having been from the Detroit area, and when I retired, I was actually working with the environmental company on my days off sometimes, and when there were transformer failures, I would go out and actually do ground samples underneath the transformers or test transformers to see if there was any residual PCB oils in them. But we can see these transformers just out anywhere, and they can fail. They're getting older. Our power grid is getting older, and these can fail at any moment. And how many times do we, with lightning strikes, or just because of the energy usage, overloading these systems, causing these transformers to overheat and then fail and catch on fire. So they're filled with oil, they're getting older, and sprinkler systems, we saw, do not work on three-dimensional fires, especially when we're dealing with a flammable liquid. When we look at a substation that was, here in New York, okay, foam and dry powders were used trying to extinguish this. Didn't work. Hazmat 1 arrived. They had F500, pull some F500 off, and within seconds they had this fire out. Okay, but because of the foam and the powders, the Purple K, and all the other things, it was a multi-million-dollar environmental impact that it was caused. Okay, this fish kill station, it goes on how these different ages were tested. It led to being a F500 being tested. When they started looking at agents that could be used on being able to suppress these transformers into high voltages, they ruled out the foams because of the bubble to bubble interaction. It was like a chain leading right back to the nozzle. So your triple F foams and your AR triple F foams were ruled out immediately. They tested encapsulator agent. And again, we don't create those bubbles. We actually change that chemical makeup of a water droplet. So in this testing, they were looking at trying to keep the current drawback down below 0.9 milliamps. So the initial tests were conducted at 50,000 volts. As I said, the AR, AFFF, and AFFF, because of that bubble interaction, failed. F500 passed. And they did it in different nozzles, different patterns. They used 3 nozzles, different flows, and the goal was to have less than a 0.9 milliamp current feedback. And this is the results. When they sat there and they used a fog nozzle at 30-degree fog pattern at a distance of 25 feet, the current nozzle was at that 0.9 milliamps. That was the limit. When they sat there and they started going into the deck gun, okay, it was 125 feet that they needed to be away for that to be less than 0.9. And then it shows a multiversal 5,000 GPM nozzle at 100 feet. So they tested all of these different nozzles and all of these different areas, and they came up with their SOGs and how to deal with these transformer fires and being able to use F500. Okay, I mentioned early on, it's a Class B fire in a Class C environment. So they're able to deal with these transformer fires so that they don't have a huge impact and they don't have a citywide blackout. Another comparison, when we look at a fixed sprinkler system that is protecting transformers. Here we have Alabama Power that had an F500 system. The transformer failed. The system activated within 3 minutes and 10 seconds. The fire was extinguished. There were no firefighters that needed to be called. It used 3 gallons of F500, 100 gallons of solution, all contained within the dike. Okay. Agent cost, $100 minimum cleanup. Okay. The company was able to remove the sprinkler system, get that transformer out, replace the stone and everything that was around it, put a new transformer in, and in a matter of days, they were back operational. But now we sit there and we look at this other incident that happened with the transformer. It was 6 hours to extinguish it with 2 departments, 400 gallons of AFFF foam, 50,000 gallons of water. The agent cost, there's $8,000. And the cleanup cost was in the millions because, again, that containment area where that transformer was located wasn't able to hold 50,000 gallons of water in solution. And again, we have that forever chemical, the PFOAs and the PFOAs that are causing the environmental impact. Okay. And do not work on the 3-dimensional fires. So we sit there and start looking at all the different codes and, adding up and doing the, the percentages, the rates, okay, with the NFPA sprays and so on, and what's recommended. And we see through all this different testing that I've showed you, okay, with Dominion at a 0.2 better than a 0.4. Okay, we look at the difference with the mattresses, how at 1% was better than 1,000 liters of plain water. So we look at applications, different methods. We saw the water-driven proportioners. We saw the balance pumps. We saw the bladder systems. Okay, we've also, as far as portable systems, we've got these turbo cannons, trailer mounted systems with deck guns, hook them up with water supply systems, response trailers. As I've said, if you are in a remote location, it doesn't mean that those transformers or those areas of your facility can't be protected. Okay, we can sit there and we can work with you as a business, with you as a fire protection contractor, in trying to help get a system in place so that we can protect all crucial areas. Okay, with our portable turbo cannons and okay, all the different areas, being able to share those SOGs that were created by FDNY and Con Edison on those standoff distances. So as you can see, F500 is a unique category of agent. It's different. It's probably very, very misunderstood. simply because of the fact that people don't take the time and ask the questions that need to be answered, the critical questions. They don't ask for a demo. Again, we are here to assist. If you're a fire protection contractor, or you have an instance where you're trying to work in I'd say that aircraft hangar, we are now in NFPA 409. So we're listed to be able to be used to protect those aircraft hangars. If again, your authority having jurisdiction, has some questions, contact us, please. We're here to help you get into these areas and enhance the fire protection systems in these three-dimensional systems. Some of the other areas that I really didn't cover it, but let's get into some of our refineries. I mentioned being able to deal with the flammable liquids, but we also work on those gases. We saw that in the introductory where we had that LG gas fire going off, and it was able to quickly extinguish it. Well, how about if we start having a leak at a refinery, or we start having a leak at a truck loading dock or station, and a detector goes off that says that we're getting into a flammable range? What would happen if a system using F500 were to go off and suppress those vapors, preventing that fire from ever occurring? Okay, or preventing that explosion, preventing those vapors from finding an ignition source. So we are trying to work with you on innovative systems. We have portable equipment. Our 2.5 gallon, our 6 liter extinguishers, our quick attack mobile units, or QAMUs, that are different sizes of 25, 50, 75, 100 liter, our portable carts. Okay, the 100 and 150 liter, 40 or 26 gallons. We talked and saw some pictures of those mobile response trailers, and then some specialized equipment when we start getting into coal, or we start getting into some grains, piercing rods. But the big thing is understanding the diamond doser. I mean, it's probably one of our go-to pieces that we recommend highly right now because of the ease of being able to install it. The low maintenance. With bladder tanks, sometimes they can be susceptible to damage because of water hammers or other things, where this is a lot more user-friendly, a lot less maintenance as far as your annual inspections and things like that. It's much, much more effective and easier. So we're here to help when it comes to being able to work with you and consulting and training. We're always open. If you have some demos, or you would like to see have a training, contact us by all means. We do a lot with the coal industry, with dust hazard analysis, emergency response planning, and training courses or combustible dust. And I mean, these are just a few. We go into lithium ion batteries and class D metals. Whatever the need is for the training, we will be more than happy to come and work with you to make certain that we get the training that you, as a industry, as a fire protection company, as a firefighter, whatever or whoever, and industry or job that you may hold, we're here to assist and hopefully help you work with us to make firefighting and our buildings and our structures safer. One not long ago was asked if I felt that building code should be changing. And as I said early on, yes, they do. And with people that are in here with us today in the fire protection industry, we need your help to get this agent into some of these codes, making the push and understanding how effective, adding this into the water stream can be, and being able to keep fires from growing out of control. And with that, I will open it up for some questions.
Thank you, Jeff. If you let me share the screen, because you share a report in Panama.
Yep.
We
Let
have
me-
that's
let me-
our
let-
distributor in Panama is here in our meeting today, and he made a wonderful job in Panama. And let me show this report, because the insurance company and the fire marshal of Panama, they want to use water, and the first proposal that they have to use 95,000 gallons of water with a density of 0.39, 0.4. And the effectiveness of contact is not defined. In the test, we can find that with 1,000 liters of water, we cannot extinguish the fire. Finally, the proposed with A500 was 35,000 gallons with the half of the density. And we can extinguish this kind of fire in 15 minutes. Yeah, we test like Jeff Joe to you the report, and this is one of the part that I want to share with you. And the other thing, because I want to your experience, Jeff, because a lot of people in this meeting are looking for an answer for a battery storage system, because lithium battery is a lot of hazard today. And I want to share with all our people here that we received this report in August of this year from the Institute of Technology of Beijing, from China. And one of the points that they make in this report, they test different agents on lithium battery. And I want to show one part of this report, and especially this part of this report, how start to grow in China. In only 1 year, they had 76 EV fires. In this part of this report, they make different study, but the most important that I want to share with you is that they found that the encapsulator agent can encapsulate here. This is the gases that you can find in a thermal runaway. See, CO, CH4, CO2, ethylene, and hydrogen. Yeah? They can found, correct me please my English, Jeff, that with the hydrogen, they test and they measure that the hydrogen was 476 part per million. When they use
Without any additives.
with nothing. That's
yes,
no trying to
without any agent,
water.
but when they use water mist in this fire, the hydrogen decreased for 270 part per million. But here in blue, when they use 3% of A500, they can decrease the hydrogen 14 part per million. One part of this report said that they found the A500, the encapsulator technology, can encapsulate the hydrogen. And in the conclusions said, if you can stop the thermal runaway here, stopping thermal runaway propagation, you can extinguish rapidly lithium batteries. They found this, that the encapsulator agent can encapsulate the hydrogen, can interrupt the free radical.
Also, sorry, let me stop you.
Yeah, please, Mike.
Can encapsulate the electrolyte right in the middle.
Yes,
So
yeah.
you're encapsulating the flammable electrolyte, so you're separating the fuel from the oxygen on a chemical molecular level, and we're encapsulating the explosive off gases. This is huge. There is no other agent in the world that has this capabilities. And here we're comparing this to the water mist. So the water mist isn't encapsulating either the electrolyte or the hydrogen. It's also saying here the free radicals, you were saying, like we talk about how we encapsulate the free radicals. The test is showing the same thing. One of the conclusions here is the cooling capacity of the 3% F500 solution was up to 3 times greater than that of water mist. And so you ask yourself, why is that? Well, because water mist, you have smaller droplets, but your heat reduction is still steam conversion, and steam conversion is not very effective. As Jeff mentioned, this encapsulator agent, we change the heat reduction mechanism of every droplet. We go from steam conversion to a term we call thermal conveyance. We are conveying the heat through the F500 molecules and around the spherical micelles that are inside every droplet. So here, what Hernan has highlighted, the sentence before that says that yes, the F500 reduces the surface tension. This allows the droplets to permeate into gaps in the battery. However, the thermal reduction of energy is a result of the micelle structure. It is not a result of simply reducing surface tension, allowing water to spread across the battery and into the crevices. No, the heat reduction is a function of the spherical micelles, and that's what we were talking about. The micelle does 3 things: encapsulates flammable liquids and vapors, as well as other materials like carbons, the CO, the CO2, but it also acts to change the heat reduction mechanism of the droplet and to interrupt the free radicals. So it has some profound effects. Did you see the acknowledgement here? The work was supported by a grant from China, and that declaration that they have no competing interest here, no financial interest whatsoever. We accidentally found this report on the internet, so we didn't have any involvement here other than to produce the F500 and sell it to our distributor in China, who further sold it to the Chinese government to do this test. But it really reinforces a lot of what we talk about with this encapsulator technology.
Thank you, Mike, for your help.
Yes.
Okay, with this, we share this document that you have more idea, that you have other solution in the markets for the different hazards that you will find in the industry. If you want to make any question, please open your microphone or write in the chat that I ask the question for our specialist. I believe, Jeff, you are so clear. But
well, I had help. Thank you for bringing up that report. Like I said, I had a link, but it works when I have the presentation, small size, but when I blow it up full screen, it link wouldn't work. So thank you for bringing that up. And Mike, as far as input with the lithium ion batteries, I mean, there's just so much to cover in all of the different areas.
Something you said that I caught my attention, and I was like, oh, I don't think that's correct. But you said the Dominion showed that 0.2 was more effective than 0.4. That was what the comment was. And I think what you meant was 0.2 density utilizing a 3% F500 solution.
Yes.
Was actually 3 times faster to extinguish the fire than 0.4 plain water.
Correct. Yes.
Okay. Yeah, I just wanted to-
I may not have been clear on that, but yes, that is the case.
yeah.
Per the video, it was showing that the F500 at 3% at a 0.2 was 3 times better than
Which is a big application for us, because when we go to NFPA 850, the sprinkler density for under turbine lube oil is specified at 0.3. So the significance of that documentation from Dominion is that we showed that, hey, 0.2 with 3% F500 was way better than the recommendation of 0.4 with plain water. So obviously 0.3 with a 3% addition of F500 would be even better. And so,
Mike, can I ask you something? Because one of the points that's in the NFPA 18A talk is about, for me, is a lot of important about the prevention. That's this technology can encapsulate not only liquids, can encapsulate vapors.
Mhm.
Can you comment something about the BIP system? Because I believe that we have some different people from fire protection companies, how we can design to protect before start the fire with the vapors.
yeah, let me see if I know we're going to divert a little bit here. Let me show the concept. If I could share my screen here. So this is Silver Eagle Refinery over in Nevada, or Utah, excuse me. And right now we have a vapor leak going on coming out of a flange. Eventually that vapor finds an ignition source and we have this major explosion. Now, this is actually the safety guy at that plant. He's in a designated smoking area, and you can see that explosion comes in along with the ensuing fireball, catches the gentleman on fire, and he running off behind. Now, fortunately, he wasn't killed, but unfortunately, this incident changed the quality of his life because he had many surgeries due to the burns that he acquired. When I look at this video, I say to myself, why are we waiting for this explosion to take place? You know, I think about this and I go, now what happens is we react to this fire. We bring out fire trucks and lots of foam and we try to put it out. One of the big issues is when we arrive on site as emergency responders, we have to shoo all the attorney vehicles out of the way because they have faster vehicles than the emergency responders, and they're looking for injured people to sue this company to run this company out of business. And I'm saying, hey, we can detect the vapor leak. We have fire panels that we can send that signal back saying, hey, we have a vapor leak here. And then that can then send a signal to the operator. Let's shut down zone 3. In the meantime, we can engage the fire pump, that which can proportion in some of the F500 encapsulator agent, and we can then encapsulate this vapor, rendering it non-flammable, non-ignitable, and non-explosive. So, you know, everything existed except the spherical micelle, except the F500. Now that we have the F500, we're like, why do we have to wait for these explosions? We can use this in a wonderful way to prevent the explosions. And one of the systems that we're working on is what we call a VEEP system. This is vapor encapsulation and explosion prevention systems. You can see how quickly we're extinguishing that fire. We're using this type of a nozzle. So this is a stainless steel nozzle. This is a Kevlar thing with very precise holes in it to get the spray patterns we need. This Kevlar sleeve actually rotates around, and it actually throws out a very nice pattern. We'll see that pattern here in a minute. No, I'll go, there you go, sorry. So you put out a very nice pattern. It's great. We can do this with water all day long, but we're not encapsulating any flammable explosive gases. Oh, we add 3% 500 in here. Man, done. No more explosion. No more people with their quality of life is changed, and we're not have to face a whole bunch of attorneys. It was this clip here at 1 minute and 10 seconds that actually gave me the idea. So what we have here is some piping. This is LNG, liquid natural gas. You can see it's on fire. This is elevated about 1 meter, 3 feet off the ground. So even if we're attempting to use a quality foam, say a UL 162 listed foam, well, we can't blanket this. Furthermore, this are pressurized nozzles spraying this LNG gas. So even if you could build a 2 meter high blanket of foam, the gas would just blow through the foam. But watch what happens here with the encapsulator agent. Okay, so this minute we turn the encapsulator agent on, we are putting out the fire, but we're putting the fire out because we are encapsulating the LNG inside the spherical micelle. So we're separating the fuel from the oxygen. We're doing it on a chemical molecular level. You see, we still have the flame, so we still have high heat, but boy, none of this is on fire back here. Prior to, oh, went back too far, prior to the encapsulator agent, you know, the flame was igniting everything coming out. The minute we just, this is good timing, because the minute we start to apply the agent, we start to encapsulate the fuel coming out. So therefore it's no longer flammable and no longer ignitable. So we're able to extinguish this, but it was this 3 seconds of video that gave me the brainchild. Geez, we can use this agent in a preventative way. Why wait for the explosion and then go put out the fire? We can do this. So in NFPA 18A, there is a new section 12.8, I believe it is, and it's called VEEP, Vapor Encapsulation Explosion Prevention. And it talks about utilizing VEEP, using manual application devices, as well as using fixed application devices. The reason they're both in here is because of something that we did with the Italian Navy. So you just saw the VEEP nozzle able to encapsulate. This is more of you'll see it's like a snow making equipment. And you can see with the 3% F500, it very quickly knocks the fire out. But if you didn't have the fire, you have nice cloud here that's encapsulating the vapors to prevent an explosion in the first place. Now, I know this looks strange, and this I like his look here. Looks strange, and I can tell you what's going on here. What's going on is the Italian Navy, after studying F500 encapsulator agent for almost 8 years, standardized on the encapsulator agents. They've removed all the foam except for the foam that was on the flight deck. And then they came back and told us, well, we have a problem. The problem is we have an aircraft carrier going through the water at 15 knots. So if we have a $30 million aircraft that crashes onto the deck, if we try to put a foam blanket on, just by virtue of the movement of the aircraft carrier through the ocean, all the foam just blows off the back of the ship. So they said, so our fire protection to protect our $1 billion ship is that D8 dozer over there. And what we'll do is we'll go ahead and just push the aircraft carrier, the airplane over the side of the aircraft carrier into the ocean. That's our fire protection. When they saw this, we were playing with this. They said, oh, this will blow the airplane out like a candle. And I know Jeff mentioned 409 and how 409's now opened up. So when you start looking at the VEEP nozzles, these type of delivery, we could easily be suppressing aircrafts and aircraft hangars using state-of-the-art encapsulation technology. Furthermore, even if you had just a spill in there, you could detect the vapors, encapsulate those vapors and the spill to prevent any type of fire in the first place. So this is some amazing technology that really, for me, is a game changer in the world.
Thank you, Mike. This is what I want to share with our people here.
Okay. Again, I'd like to thank everybody for being present and taking time out of your day. Enjoy it as always. I think there was some really, really good discussion, which is what these webinars are for, what they're all about, you know, answering those questions, getting that knowledge out, more knowledge that we give to people about the product. The more we sit there and we stop the misinformation and the things that people say about the different agents. But you know, I enjoy doing them. I appreciate your time taking out of your day. Please join us again. Hernan is going to share this. Any questions come up later on, don't be afraid to contact us, ask those questions. We're here to help. We want to answer. We want to be helpful. We, as we said at the beginning, want to encapsulate the world, making it safer. So please enjoy the rest of your day, evening. I appreciate your time. Thank you very much.
Okay.